First, and perhaps most evolutionarily primitive component is what he calls id, perhaps in a nod to Freud, though there is nothing Freudian about this subsystem. In fact, it is short for intentionality detector. The job of id is to detect animate or living things in its environment. In terms of its functional profile, id is activated by the perception that an object is moving in certain ways that suggest that it's alive. More on this in a second. Then, what it does is that it attributes goals and desires to that object. You can say that it reads or interprets motion in terms of goals and desires. Goals and desires are basic or primitive mental states, in that they are needed to make sense of the behavior of all animals, in terms of approach and avoidance. These are the most primitive type of volitional states, where the term volition, by the way, is a word of Latin origin that has to do with the will, as when you say, they chose to go of their own volition, meaning they left because they wanted to do so. Id is activated whenever there is a perceptual input that could identify something as an agent or as an animate. What sort of input is that? The answer is self-propelled or self-caused motion with a direction. Whenever we perceive something that seems to move of its own accord, rather than being pushed and pulled by external forces, we readily attribute agency. That is, the capacity to do things, as opposed to things just happening to one, as in the case of inanimate things like rocks or water. In attributing agency, we're also ascribing specific goals and wants, depending on what's going on in the scene we are perceiving. It will interpret this as it wants to go there, and this as it wants to get food, and this as they want to win. Notice that this is a very basic mechanism, and that its inputs must come from the senses. The most prominent source for humans is vision, of course, though it can also receive inputs from audition. For instance, we might interpret an insistent, rhythmic scratching sound as that of a pet trying to get in the house, or an ear-splitting screech as a cry for help. In fact, it can work with any sensory modality. That's why it's said to be amodal. Likewise, it is form-independent in terms of its stimulus sensitivity. The stimuli can be of any shape, so it can be triggered by a familiar human figure, or by something relatively shapeless like an amoeba, or perhaps like a cloud, or by something with little structure like a stick or a geometric figure. So it is very general in terms of the stimuli it can work with. In short, anything that can be interpreted as exhibiting self-propelled directional motion tends to be read as an animate being in possession of goals and wants. What is the evidence for the postulation of such a faculty? Baron-Cohen cites several sources of evidence, including dissociations and comparative studies, but I will focus on his use of Hyder and Simmel's pioneering study. I'm going to show you a clip, and then you're going to describe what you saw. You may want to narrate the events to yourself as you see them, or perhaps write your impressions afterwards. If you are like most people, then you use all sorts of mental terms to describe what was going on with the figures. In particular, you attributed them goals and desires. For instance, one of Simmel and Herder's subjects described the events in this way. A man has planned to meet a girl, and the girl comes along with another man. The first man tells the second to go. The second tells the first, and he shakes his head. Then the two men have a fight, and the girl starts to go into the room to get out of the way and hesitates and finally goes in. She apparently does not want to be with the first man, and so on. If by chance you came across this description and you didn't know the context, the last thing you'd imagine is that what's being described is a bunch of triangles and circles moving around. You'd perhaps think it's a soap opera or something of the sort. Notice the blatant attribution of human qualities to the figures, including plans, desires, and emotional states. And all of this is done effortlessly and in the most natural way. In fact, it is hard to refrain from interpreting these clips as involving little beings with their own agendas. These results have been widely replicated in many populations, including children. However, one of Hyder and Simmel's subjects provided a different sort of narrative, one that did stick to geometric and physical terms. It went like this. A large solid triangle is shown entering a rectangle. It enters and comes out of this rectangle, and each time, the corner and one half of one of the sides of the rectangle form an opening, and so on and so forth. Well, this is hardly the stuff that makes for compelling daytime TV. This phenomena illustrates the fact that we have a very strong inclination to attribute goals and desires to things that appear to move on their own. This is very hard to suppress, and shows up even when we know that the things in question are strictly inanimate and thus cannot have any intentional states. The next subsystem we're going to discuss, and which works in parallel with id, is called ED. ED is short for Eye Direction Detector. The most basic of ED's functions is a detection of eyes. So ED is activated in the presence of stimuli that look and behave like eyes. Its second function is to determine the direction of the gaze, where the main question is it directed towards me or towards something else? This distinction between eyes that look at me and eyes that are looking at something else is of course very significant. Baron-Cohen reports evidence that mutual gaze triggers physical arousal, often pleasurable, as happens in the interactions between a baby and its mother, and sometimes aversive when it is interpreted as a threatening display, as observed in many species of non-human primates. Okay, back to eye direction. If the eyes are aimed towards something other than one, then ED determines the specific direction of the gaze. Finally, ED goes beyond mere physics and geometry and interprets the gaze as seeing, as a kind of mental state. So it determines what the organism is seeing. It does that by combining information about the angle of the gaze and about the objects in its path, together with the general principle that if the eyes are directed towards a particular thing, then the organism is seeing that thing. For instance, if the angle of the gaze determines a path that meets an apple, ED delivers the verdict that the organism is looking at that apple. This is probably a relatively ancient mechanism, and it's not only present in humans. In fact, evolution has repeatedly exploited this feature, as in the case of the owl butterfly, whose eye spots have the effect of deterring predators by signaling the possible presence of a big creature lurking in the vicinity. And humans in Africa, imitating nature, have found that painting large eyes in the backsides of cows can keep lions and other predators away. So, in summary, ED uses visual stimuli to tell you what different organisms are seeing. More specifically, it is activated by eye-like stimuli, and it outputs representations that attribute basic perceptual states, like seeing, to organisms. So it interprets eye-like stimuli as indicating the presence of an agent or experiencer behind those eyes. The previous two components were part of the 1990s mind-reading model. The next one was added in the 2000s, and it's known as TED. No, not this TED. We're talking about the emotion detector. TED is in charge of telling you what the person in front of you is feeling. To do so, it avails itself of a kind of primitive state that is different from those of id and ED. We're talking about affective or emotional states. TED outputs attributions of very basic emotional states such as sadness or anger. TED is a modal in that it is not essentially linked to any one particular sensory modality, since information about people's basic emotional states can be picked up from their facial expressions or their vocal intonations, or even from their touch, say whether it's tense or relaxed. So TED can make use of all of this sensory information to deliver a crude report of an agent's emotional state, as in mom is angry or dad is happy. Okay, let's take stock and compare what we have learned so far about the most basic systems underlying our mind-reading competence. First of all, they are all similar in their developmental timetable, in that they normally appear within the first 9 months of life. In terms of their inputs, id and TED are similar in that they are both amodal. However, ED can only work with visual stimuli. Likewise, id and TED can be triggered by stimuli of different shapes, whereas ED is exclusively sensitive to eye-shaped visual stimuli. In terms of their outputs, each of the systems delivers representations with different kinds of primitive states. Id yields representations of volitional states, such as wanting and goal possession. ED outputs representations of perceptual states, such as looking and seeing. And TED produces representations of affective states. We can also classify them in terms of the adicity of their output representations, which means the number of participants in the events or states they represent. In this case, all of these systems deliver representations that are at most dyadic, that is, representations with at most 2 participants. With respect to id, for instance, wanting is a relation between 2 things. One is the agent that does the wanting, and another is whatever it is that the agent wants. So the representation of a state of wanting must be dyadic, since it has 2 participants or arguments. Likewise, the seeing relation is also dyadic, since it relates a seer and an object being seen. However, we'll soon see that mature mind reading requires us to go beyond dyadic representations, but such representations lie beyond the capabilities of the subsystems we've discussed so far.